In this CCTV camera, I found this capacitor, polymer capacitor, short circuited. Its code is DA7. It is polarized capacitor. This bar side is anode, that is positive terminal. This side negative. It is SMT, surface mount technology, tantalum polymer capacitor. It was giving short circuit. Its number is DA7. Marking on PCB C39. That's here. Let's check this capacitor. What is the value of this capacitor? What is voltage rating? What is capacitance? In millimeter. First we will take its length. .5 length 3.5 0. Now we will take width. .8 height, this thickness, it's 2.0. Height 2.0. Remove the dots. 3528-20. In Google Chrome, type here 35280 polymer capacitor datasheet. 3528-20 polymer capacitor. Downloaded datasheet. Polymer surface mount chip capacitor, high performance type. We will check the package code, case code. In our case, 3528-20. This is code, EIA size code. There is 3528-12, but we need 3528-20. 3.5 millimeter length, width 2.8, and height 1.9 plus minus 1. It is 3528-20 and its code is B, case code B. Now we will go to case code. Here is marking, A case marking in 4 digits, but in our case T, B, Z, V, D, C cases 3-digit marking. The first simplified code for rated voltage. Here is voltage rating. In our case D is for 20 volt. So this capacitor 20 volt. Then the next 2 digits for capacitance. A7 is 10 microfarad. So this capacitor 10 microfarad, 20 volt. There is another capacitor on this board that was in parallel to this one. That's also the same marking code, DA7. Both capacitors were in parallel. We will check capacitance of this capacitor. That is this one. Yes, it is 10.24. Exactly the same. DA7. D, that is 20 volt. A7, 10 microfarad. We verified the capacitor as well. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Brown, black, black, gold, black. A resistor value. This is a question from my viewer. We have a resistor, brown, second black, third black, next gold, last black. What is the value? First brown is 1. If we see color code chart, 1, 0, this black multiplier, that means there is no 0. So multiply by 1, gold, plus minus 5%. Then the last black, it is wire wound. Wire wound non-inductive resistance. Non-inductive. It is 10 ohms plus minus 5% non-inductive wire wound resistance. In this type of wire wound resistance, when it is indicated with last black color ribbon, it has 2 layers of wire. If first layer is clockwise, the second layer is anti-clockwise. So second layer will cancel the magnetic field of the first layer, so it will not become an inductor. It will be used as a resistor. So that is called non-inductive wire wound resistance. Thanks for watching. My tablet has an area on the display that does not respond to the touch. A troubleshooting example, please. This is a question from my viewer. I don't have tablet. I will use this old model telephone from Samsung GT5830, and we will see how this touch works and if there is possibility to troubleshoot, to repair it. We will see how this touch screen digitizer works. In this model, the touch panel is separate and display screen is separate. In some models, the display screen and touch panel are as a one piece, connected to one connector. Touch can be separated from this connector, and in some models, touch is permanently fixed with the LCD panel. So manufacturers are using different options. First we will see how it works. This touch screen digitizer is divided into rows and columns. Rows these are rows and these are columns. C1, C2, C3, C4, C5, C6, C7, R1, R2, R3, R4, R5, R6, R7, R8, R9, R10, like that. In the back side of this transparent glass there is this display that is called IPS display, and this transparent glass is here. When we will touch in any portion of this glass, basically we are touching these rows and columns. In past there was resistive touch screen, but now it is capacitive touch screen. These will sense the touch area and these will decode that here in this portion the capacitance is changed. It will sense row and column reference. The IC will decode this data and it will send to host computer. Suppose processor is showing different icons here, contacts here. If I will touch this portion where the contacts icon is visible, that means I am pressing this area. Row 9 C2, that is reference for that icon. So processor will open that file. Here is gallery. If I will touch it this area, R5 C5, it will open that file. That file is linked with this reference R5 C5. We are touching here, processor will read this address and it will decode the portion of this icon and it will open the linked file to this icon. Let's compare with microwave oven. In the microwave oven we have selected numbers 1, 2, 3, 4, 5, 6, 7, defrost, fish, cook, barbecue, like that, and we will select only that options. But this is multifunction display. Processor will show different options here, so we will touch this portion, but here the options are changing all the time. There is printed number on the microwave oven, but here no number is visible here on this transparent glass, but this matrix is similar to that one. It will work row and column method. Now we can see here is this IC, digitizer IC. From this IC there are different lines coming to this side. This is input connector. It is reaching to this IC. In the second side of this IC, there are these lines, rows and columns. From this flex cable, it is communicating with this touch screen. All these lines are entering in different portions. These are rows, then this side, and these are columns. Now if I will press in this area, that time this row and this column, row 1, column 1, row 2, column 2, this portion. If I will touch here, the capacitance in this portion will change due to human body here in this portion. So this zone will be marked and this data will reach to this IC. It will decode that data and then it will send to host computer. Now if there is problem in this touch panel, there is no option to fix this touch panel. as it is asked in the question that portion of this touch screen is not working. If capacitive touch screen is damaged, its crystals are short circuited, leaked, then there is no option. So basically we are changing the capacitance on this paper, that is divided into columns and rows. So if there is something wrong, we cannot do anything. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. I have this 500 watt inverter. It turns on, but it does not provide output. Let's troubleshoot it. These two lines are positive lines. This one at this fuse and this wire at this fuse. This is negative line. This negative line is reaching here and then it is jumped here. So it will drive these two transformers. LED is turned on, the voltage are fluctuating at input. And if I check AC output, there are just only 2.5 volt AC outputs. Let's check what's wrong here. First we will check this capacitor voltage, 400 volt capacitor, DC voltage. There is fluctuation. That means there is some short circuit condition, that the circuit is starting and then off, then reboot. Check output transistors, output power MOSFETs. Good. Yes, this is giving short circuit. 11 NK50. It's good. This one is damaged. This is short circuit. Yes, this capacitor is damaged. It has visible crack. Yes, now the red light is finished. That's good. We have 263 volt. 133 volt because one MOSFET is missing. (20N60) 11N50 (20N60). Now let's check DC voltage. 263 volts. Two J103J. I don't have this capacitor now, filter capacitor now. I will arrange this capacitor 2J103J and I will arrange this MOSFET. I will connect this 60 watt tungsten lamp because this time I am turning it on without heatsink. Yes, that's great. Yes, it is 215 volt. That's good. Because this time the filter capacitor is not installed. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. One diode, open circuit. Gate, MOSFET on, reverse the leads, MOSFET on, touch to gate, one diode, channel off. This MOSFET is good. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. Delta Electronics 24 volt power supply not turning on. Let's see what's wrong here. If you don't have good experience in electronics, never try to repair because here are live voltage. Always take care for the safety. Line neutral. I will apply power using series lamp and we will monitor the lamp condition. There is no indication on the lamp. Set multimeter to AC. $228 volt. If we check output, no output and LED is off. First indication that this capacitor is damaged. We can see the sign on this mat. The K is printed on the capacitor. This K sign is printed on the capacitor. That means this capacitor is damaged. We have some damage sign here. In this area there is damage sign. In this portion. That is, yes, this portion. At very first step or any time we want to work on this board, we need to verify voltage on this capacitor. This capacitor must be discharged. If there are some voltage, we must discharge it using capacitor discharging kit. DC voltage, no voltage. First of all, we will inspect it and we will see any visual damage, burning sign. Yes, this is damaged area. This portion might be it is water damaged. Now I will clean it. Now I will check fuse. Fuse damaged. Fuse open circuit. I will use 1 ampere bus fuse wire for troubleshooting the circuit. Now we will check MOSFET. This MOSFET is short circuit. (20N60 C3 MOSFET). Short circuit, short circuit. Gate, so drain, source. All pins are short circuit. Now we will verify the bridge rectifier. This is cut side, positive terminal. Black lead at positive terminal. One lead at input terminal, one diode. Second input terminal, second diode. This is good. Move the lead to negative terminal. Open, open. Reverse the leads. Red lead at negative terminal, one diode, second diode. Red lead at positive terminal, so it is good. Now we will check these standby circuit rectifiers. Good. Before repairing this section, we need to verify standby section. Now I will apply power. There is a relay click sound. DC voltage 317 volt, 11.26. Good. Now the standby section is clear. Now I will check voltage at output stage. So its power stage is also working good. I have this 20 and 60 C3 MOSFET. This MOSFET was short circuit, the original MOSFET. This is short circuit. One diode, open circuit. Gate, MOSFET on, reverse the leads. MOSFET on, touch to gate, one diode, channel off. This MOSFET is good. Resistance 30 ohms. Gate discharge resistor is good. From here to pin number 8 of NCP 54, this is good. So now I will install this MOSFET. Our next stage is capacitor. Might be at 220 volt, the capacitor is working good. But at high voltage, maybe its dielectric will make short circuit and it will not maintain the voltage. Might be in no load condition, the circuit will work normal. But when we will apply load, that time it will damage again. So we need to replace this capacitor as well. Now first we will verify it. DC voltage. Now I will connect power. Yes, PFC circuit started and it is taking too much time. The voltage are maintained now. Now I need to arrange a capacitor, fuse. This circuit is now recovered. Now the circuit started working normally. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. While working on an audio power amplifier, I detected this potentiometer was not working properly, so that was causing hum sound. There was sound distortion. Two potentiometers were bad. I purchased two new potentiometers. These are fake. Let's see. When we say potentiometer, it is a resistor between two pointers and the third pointer, that is slider. From here to this point It is 100 kilo ohms resistor. 100 kB. B, that means it is linear potentiometer. If there is A, that is analog potentiometer. 100 K resistor between outer terminals, this point to this point. It will divide the resistors between this point and this slider, this point and this slider. It is stereo potentiometer, 2 stages. The second stage is also 100K. When I purchased this one, it is B100K. That means it is linear 100 kilo ohm potentiometer. If we check its resistance value, it is 54.5K. That's wrong. The second stage 57K, while the marking on the component is 100K. If you check this one, 53K, and the second side 54K. This stage 54K. So it is falsely marked component. The actual it is 50K potentiometer, 2.2 ohms, 54K. So it is bad component. If I will install in place of 100K, it will not divide the voltage properly. It will not attenuate the signal as it was working. So there will imbalance in the sound. When we purchase a new component, especially like potentiometers, we must verify its resistance. Either the resistance is good or not. If we check its linearity, it is dividing linearly. So its linearity test is good, but its total value RT is wrong. So I will return these parts to the seller and I will purchase new 100K potentiometers. Thanks for watching. Now I am rotating clockwise and we can see the voltage are increasing linearly. This is linearity test of a potentiometer. This is bad, this is good. In last video, I shared that I was sourcing these 100 kilo ohms potentiometers and I received same 100 kilo ohms, but these are fake. While testing, I explained that its linearity test is good. I received comment from my viewer that what is linearity test? This is a potentiometer. It has specific resistance value from one end to the second end. 101.5. Resistance between these two terminals 101K. And resistance between these two terminals will change with the position of this knob. Basically, when we are moving this slider right or left, clockwise or counterclockwise, we are tapping the resistance from this resistive element. And we take resistance between these 2 points and these 2 points. Basically, it is a voltage divider network. What is linearity test? There are two types of potentiometers. If we see its part number 100KB, that means 100 kilo ohms. B, that means linear or analog potentiometer. There is another type 100Ka. That A will indicate that is log pot. In this potentiometer, the resistance will increase gradually with a standard ratio between this arm and its position. You can say this is resistance 100k or any value, and this is rotation from counterclockwise to full clockwise from this point to this point. When we will move clockwise or counterclockwise, if we are taking between these 2 points, the resistance is increasing like this. When it will reach at maximum end, that is extreme position in any one direction, that time the resistance will this. Let's suppose this one 100k. If we will place this knob in center, the resistance value will 50k. Similarly, if we divide 3/4 position, the resistor value will 75k. 1/4 position 25k, like that. So resistance is increasing linearly. It is called linearity. When we say log pot, that will change in this direction. When we say log pot, that will behave like a moon curve. I don't have log potentiometer now. I will arrange that one and we will make practical testing. We can test linearity by 2 different methods. The first, that is a resistance mode. Now the multimeter is in automatic mode. If I will connect these leads together, it will move to lowest range to adjust the maximum display. When I will use this 100k, it will use automatically 100k range. When we want to test it, we will connect to outer terminals. It is the best way. Just press range button. Now we are in manual range. Now it will not switch to lower range for showing more accuracy. Now it will move from 0, 1, 1k, 2k, 3k, like that. It will not move in ohms. Now if I will rotate this potentiometer, there is no jumping or no bubbling. If any potentiometer will start jumping, bubbling, its resistance value will increase or decrease randomly. That potentiometer will not good. At the final end, it is showing 0 resistance. Now we will shift slider to this end. 101.6k. Now I will move to clockwise position. At the final end, it must be 0. Now if I will rotate to counterclockwise, same way I have this potentiometer, it is 2.5k. I will use this range to display maximum reading. Now if I will connect between slider arm and this point, here it is not showing anything. This potentiometer linearity test is failed. We can see the resistance between outer two terminals is just only 2.5K, but it is showing a random resistance value. Here it is showing 2.69K in one side. If I will test between these two terminals in full clockwise position, it is showing some resistance 0.15K, 150 ohms. And now if I will rotate it counterclockwise, we can see its resistance is increasing. Sometime it is disconnected, 1.1K. Then 44K, 33K. So this potentiometer linearity test is failed. At full end, it is showing open circuit. This potentiometer is not good. Now we will apply voltage. That is best way to test linearity of a potentiometer. I will connect 5 volt at outer terminals. I will use multimeter and I will connect common lead of the multimeter to common point and positive lead to the positive terminal. It is showing 5 volt and I will press range button to enter in the same range. That maximum voltage level is 5.1 volt. Now I will connect to center pin, slider arm. Now the multimeter is in manual range mode. At full counterclockwise, it is showing 1.2 volt. Now if I will move to clockwise position, here it is showing 0. Sometime the voltage will appear. Here it is showing 3.6 volt. So this potentiometer linearity test is failed, that its resistance is not changing and its voltage dividing capability is not good. Here the linearity is failed. In this portion it is stable. .81, 2.0, at full clockwise it is 0.001. Now let's increase again. Until now it is stable. .8, 4, and after 4, 4.2, it is now disconnected. This is the problem in this potentiometer, that its linearity test is not good. We will change the input leads. Now we will connect ground here and positive 5 volt here and common in this side. Now we are checking the second side of the potentiometer. In full counterclockwise position it is giving 0. Yes, there is a sudden jump. Here 0.014, then it is intermittent. We can see it starts immediately with a jump. This jumping of the potentiometer is not good. Yes. This sudden increase is not good. Then it is dividing the voltage. .5 volt, 3.7, 4, in one direction it is starting from 0 side until 0.47 it is remaining low. Then above than 0.4 volt it is dividing the voltage linearly. So one portion of the potentiometer is damaged. So if we test this one, common here, and we will connect power supply common at this point. Multimeter in the center, positive supply at extreme right position. Full counterclockwise. Now I am rotating clockwise and we can see the voltage are increasing linearly. There is no sudden increase, there is no jumping or bubbling. If I will leave it here, the voltage are stable. If this voltage will fluctuate, that potentiometer is not good. And potentiometer must divide this voltage from 0 to maximum. If it is starting from this point above than 0, that potentiometer is not good. If any potentiometer is disconnecting the signal before the end limit, that potentiometer is also not good. This is linearity test of a potentiometer. This is bad, this is good. I have this 12 volt 10 ampere power supply, no output. Let's fix it. If you don't have good experience in electronics, never try to repair, because here are unisolated live voltage. Take care for the safety. I will apply power using series lamp and we will monitor the lamp condition. I will apply line and neutral on these two terminals. The lamp draws current, that means its input circuit is clear. AC voltage 235.9 volt. Check DC output. No output. Let's open it. Never touch any component in this portion. Even the power is removed. Might be this capacitor is holding charge and it will give severe electrical shock. UC3842 IC. First we will verify voltage at pin number 7 and 8 with reference to pin number 5. 5 number pin is ground of this IC. Pin 7 VCC and pin 8 reference voltage. DC voltage really fantastic, 54 volt. Reference voltage minus 120 millivolt, but 54 volt at VCC pin. That means there is no chance of this IC. It means its VCC circuit is good, startup resistor is good. Maybe VCC capacitor is also damaged. And if there are 54 volts, that means this IC surely damaged, because there is 34 volts or 36 volt clamping diode in this IC. Before working on this circuit, verify voltage on this capacitor, 45 volt. Now it is in safe limit. In the first step, I will replace this IC. When we have 54 volt on this VCC pin, that means there is no chance for this IC. It must be damaged. Yes. This is the damage sign on this rosin. Yes, we can see this crack. Yes, it is UC3842. I will verify this capacitor as well, because it is exposed to voltage above than its limit. .8 microfarad. 100 microfarad, 35 volt. Now I will verify its ESR value. Its value is 99 microfarad, 0 ESR. That means this capacitor is good. I will use the same capacitor. I will verify this VCC rectifier. It's good. Let's check it now. Yes, that's great. The LED is on now. If you enjoyed this repair process, give a thumb up. If you have any question, please write in the comments. Thanks for watching. In last video, video number 1205, I repaired this power supply. Just 12 volt 10 ampere power supply. The problem in this power supply that IC here UC3842 was damaged. It is the best technique when we are repairing UC3842, 43, 44, 45 base power supplies. We must check VCC voltage. Then the next, reference voltage. When I tested, I found 54 volt on pin number 7. Pin number 8, just few millivolt were there. I received too many comments from my viewers. I will read that comments and I will explain why there were 54 volt in this power supply. First comment here, hi Haseeb, after you repair, how much voltage to ground you get at pin number 5 and 8 when energized? That means if the IC is good, how much voltage will there at pin number 8? I will explain pin number 7 and I will explain pin number 8. If you don't have good experience in electronics, never do this experiment. Never try to repair because here are live voltage. Always take care for the safety. DC voltage. In initial stage, it will take 16 volt from this capacitor. I will explain in detail. And then from transformer, bias winding, auxiliary winding, VCC winding, it is receiving 11.64 volt. There are two channels of current, one from this capacitor, the second from this transformer. This time we are receiving voltage from this transformer that are 11.6 volt. 1842, 2842, 3842. 1843 UC 2843, 3843. 1844, 2844, 3844, 1845, 2845, 3845. These all ICs behave same. Just only there is difference in VCC voltage at pin number 7. But reference voltage are same even at 3846. at pin number 8, 4.995. These are standard voltage, 5 volt. If any IC is not providing 5 volt, that means that IC is not good, because within this IC there is a reference good circuit. That block within the IC will monitor voltage all the time. If any time the voltage are less than 5 volt, 4.995, if the voltage are less than 5 volt, this IC will go in disable state. Then thank you for sharing. Peace be upon you. I have power supply. The cooling fan used to work. That is not related to this video. I will discuss separately. Thank you so much. God bless you. I am also thankful for your comment. There is 54 volt at the legs 5 and 7 of the PWM IC. You only change the IC. There should be still 54 volt. This voltage is too high or not? I am not able to understand the situation. No problem. Why there are 54 volts? I will note down the questions. Then, excellent, Mr. Haseeb. Thank you. What do you think caused the failure of IC? Why IC damaged? Then, sir, make some video about Dell monitor SMPS repair videos. Okay, I will try. Then, good morning, sir. Camera is zoom out too much. This is biggest headache for me, because I am not good in videography, or I am not good in pictures. Even I don't use my camera to take selfie. I am far away from this subject. So this is reason most of the time the video is zoomed out. There is blur, defocusing, like that. But no problem. Still I am trying to fix this problem, and I hope someday I will make it better. How do you verify VCC rectifiers? The next question, why was the input voltage 54 volt but no other parts damaged? I don't see how voltage was 54 volt. Where was that voltage coming from? I will explain by making a circuit diagram and by checking practical circuits. Then I also have same doubt. Okay, then same question came to my mind. If there is 54 volt reaching to VCC pin, then why the new IC not damaged? Please, Mr. Muhammad, can you explain? Yes, sure. Then the next, notice that this voltage is on no load. Since the circuit was open, it is normal to reach such voltage under no load. In our case, the load is IC. Yes, this is right. Exactly, this is a good comment here. Then G4ZBK7CT, any voltage will not double or triple even with no load. You are just wrong. Delete your useless bad post now. I don't know he is replying to this upper comment or he is saying to me. If he is replying to this comment that these voltages are with no load, then I think this comment is somewhat not good. I respect for every opinion of my viewer. So if he is saying about my video, so my video is perfect and 54 volt are normal. Electronic components are working with smoke. When some smoke come out, they no longer functioning. Yes, it is the reality of the components. If any component damaged with smoke, without smoke, it is the same. When its junction, if it is semiconductor, when it loses its specifications, then it is no furthermore. The semiconductors are much sensitive. Then the next question, Electrical characteristics section says VCC 15 volt and reference section of the datasheet says VCC 12 to 25 volt. I don't know what is the VCC in 3842 IC. This is input section. After EMI filter, the voltage are reaching to this bridge rectifier, positive negative terminal. We received positive voltage and negative voltage from where? From this bridge rectifier, that is here. These voltage are reaching to this main capacitor. Here is capacitor. Then these negative voltage are reaching to this point. From here to here there is a resistor, this one, that is this resistor. It is connected between source pin of the MOSFET and ground, and positive voltage from here, these are reaching to transformer primary winding, one end. Here is MOSFET. At the source pin, here is our current sense. This end is connected here. This capacitor negative terminal. So current will flow in this channel when this MOSFET is on. If this MOSFET is off, that means there is no current here in this primary winding and there will no current in secondary winding. Same time, we have third winding here, that is called auxiliary winding. One end of this winding is connected directly to ground, that is auxiliary winding, bias winding, VCC winding. That means if this transformer primary winding is off, there is no current flow in this channel until it will receive any pulse to turn on this gate. To provide drive signal here, gate drive components here. These components from here, resistor, and it is coming from pin number 6 of UC3842. 3842, 3842, 43, 44, 45. These all ICs are approximately similar. This is pin number 6. This IC needs biasing voltage. For initial startup, here are two resistors in parallel, 200 kilo ohms, 200 kilo ohms, that are connected between these 2 points, and it is positive terminal of the main capacitor. Then from here to here, the second resistor, that's this one, 43K, 4330s. That means 200K, 200K, two resistors in parallel. The RT will 100K, equivalent resistor. 43K. It is connected to pin number 7 of this IC. Two resistors in parallel, 200, 200. Resistor in parallel, 100K, and this 43K, for 143K resistor connected to pin number 7 of this IC. This is pin number 7. Pin number 7, here is a capacitor, that is this ceramic capacitor. It is to remove ripples for filtration. If we see this line here From here to this point, here is a jumper, this J2, and it is reaching to capacitor negative terminal. That means at pin number 7 we have this capacitor and it is connected to ground line. Next component here, this one. This is polarized capacitor. Normally it is 50 volt capacitor, but I don't know why in this circuit here is 100 microfarad 35 volt. Almost every power supply uses 50 volt. That means in parallel to this ceramic capacitor, this capacitor 100 microfarad 35 volt. If I will simplify this circuit, 143k resistor, that is this one, is connected to pin number 7 of this IC, and there is a capacitor connected to ground. Ripple removing capacitor is in parallel. Here we applied 310 330 volt DC. Because voltage applied here at line terminal are rectified and peak voltage are stored here. 220 here or 230 here, 330 here. AC voltage multiply with 1.414. When we connect it to this higher voltage, and this capacitor is 35 volt DC, that means it will start charging. When it will start charging, this is point to be understood. Here is current and here are voltage. Let's see 3842. When we connect here and this capacitor is at zero potential, that means pin number 7 of this IC is also at the same potential. When there are 0 volt, this IC is off. Current here will flow. How much current will flow? V divided by R. It will depend on the resistor value. If resistor value is too high, the low current, minimum current will flow. But in this case, 310 divided by 143, 2.23 milliampere. 2.23 milliampere current is flowing in this channel to charge this capacitor. When the capacitor will start to elevating the voltage, the current will decrease. But normally we can say 2.3 milliampere short circuit current will flow in this channel. Capacitor is charging. This IC will receive that rising voltage at this pin. Normally 0.3 milliampere, 300 micro to 500 micro, 0.3 milliampere to 0.5 milliampere maximum is standby current. This IC will not work. The voltage are increasing until it will reach at 16 volt. When this capacitor will obtain 16 volt, that means the IC is also receiving 16 volt. That time the internal voltage comparator, VCC comparator, will turn on this IC. Before this, it was receiving 0.3 milliampere. Now the capacitor is charged at 16 volt. At 16 volt, this IC turned on. When it turned on, it will start to consume 17 milliampere. We can see at this current it started. The IC is biased up and its chip is now consuming 0.3 milliampere current. That is very low current, and this channel is providing 2.23 milliampere current in this path. When this IC started switching to drive this transistor, this MOSFET, that time it is consuming 17 milliampere current. We are receiving 2.23 and it needs 17 milliampere. From where it will receive? It will receive current from this capacitor. When this capacitor will start to discharge, its voltage level will start to decrease. When the voltage level will decrease until 8 volt, this IC will turn off again. It started switching. This is a specific time. It will depend on the microfarad of this capacitor. When it started switching, it is switching this transformer. When it will switch, we will receive output voltage here. Same time it will generate voltage in this VCC winding. In this VCC winding, this end is connected here to this rectifier. That is this one. This is D7 VCC rectifier transformer. This winding end will produce voltage to this rectifier. Then there is a resistor here that is in series with this one. It is VCC setting resistor. This resistor is used to adjust the VCC voltage. I can say it is jumping here, then this voltage, this resistor and this voltage are reaching here. When it started switching in this portion from 16 to downward, capacitor is discharging. If this transformer will produce output, that time it will receive smooth running voltage, enough current that is above than 17 milliampere, above than the required current of this IC. That time this capacitor will maintain voltage. Otherwise it will keep discharging until 8 volt. If this circuit is failed due to any reason, IC damaged, this damaged, whatsoever, it will not receive a required voltage at this capacitor. So this capacitor will discharge. When it will discharge, this IC will stop switching and here it will turn off. Here it was receiving 16 milliampere, but now again when it will turn off, IC is off, the capacitor will start again to charge at this current and IC will start to consume this current. We can say this IC will change from 0.3 milliampere to 17 milliampere for powering on, and when it is going in off state, the current will decrease to this value. Now this is the working phenomena of this IC. If this circuit is working good, that time we will receive voltage from this VCC winding. What happened here now? When this IC was damaged, here is polar capacitor. All these capacitors are polarity sensitive and voltage value sensitive because these are polarized capacitors. In forward condition, we apply positive voltage at positive, ground at ground. If the voltage will reach at this level 35 volt, until this voltage value it will remain safe. Normally the voltage value is considered 20% to 30% less than this value. That means the circuit will work around 20 to 25 volt, but the maximum voltage value 35 volt. If any circuit is feeding more current, there is potential difference. Why? This capacitor is 330 volt capacitor here now. Basically it is 400 volt. but the circuit that is feeding current from here, that is maintaining 330 volt at this line, and this capacitor is now just 35 volt. In case this IC is damaged, there is potential difference. Here is 310 volt, 330 volt DC at this rail. If this circuit is not consuming current, when it was consuming, it was requiring 17 milliampere for powering on, but normally this will not provide enough current because it is providing just only 2.23 milliampere. That means it is controlling the current. But if this load is off, this IC is damaged. It has 36 volt clamping diode inside this IC. If this IC is now failed, then the voltage value will exceed than 36 volt. That time its internal clamper diode will start functioning and it will keep discharging the voltage, this current. But maybe at specific limit or due to 100 microfarad value, maybe this diode is damaged. When it is damaged, its internal body will damage again. Let's suppose now this IC is disconnected from the circuit. Either it is removed or it is damaged. If it is short circuit, that is different condition. That time it will not allow to produce voltage to this circuit. That time pin number 5 is connected to ground. If this IC is short circuit, it will allow all 2.3 milliampere current to the ground. Current flowing here will keep discharging. Normally it is blocking inside. That is short circuit condition. That time we will not find voltage here, or maybe 1 volt or less than 1 volt will there on this capacitor. But if this IC is damaged, this is second condition. What will happen now? Now due to potential difference, when we are feeding current here, because there is no consumption here. Before this at 16 volt, this IC was dropping the voltage value here. But now the voltage are increasing. When it will increase approximately 10 to 20% above than the rated value of this capacitor, its dielectric will become leaky. It will become weak. So it will behave like a resistor. This capacitor now will act as a resistor. If this current is low, that time it will keep discharging and its internal temperature will start to build up. If this current is high, that time it will blast. But due to this high value resistor, it will keep discharging the voltage here. When I was repairing that power supply, the same time, after recording that video, I received comment from my viewer. He is facing the same problem.
الفي سي سي صار رجعت شغلت الفي سي سي 70 وما ظل بيرهف ما ظلش يعني الفي سي سي طلع.
This viewer was facing the same problem. His circuit was 70 volt. In my case 54 volt. Why? Because the capacitor value is 35 volt. In his circuit the capacitor value was 50 microfarad and voltage were 70 volt. This IC damaged, it will not make a load on this path. That time this capacitor will keep charging, but it will act as a resistor. Its dielectric will not hold the charge, it will start to leak the current. When current is flowing, its internal dielectric temperature will increase. If the current is somewhat high, that will cause to blast this capacitor. Because current is being controlled, that's why it will not blast. We will find high value voltage here. Let's suppose if I remove this capacitor here and I place here 400 volt capacitor, that time it will store 400 volt, because dielectric of 400 volt will deal with 400 volt. This capacitor can deal up to 50 volt because it is 35 volt plus 20%, 30%, and then its limit is bypassed. This question, why this IC damaged? Because these are semiconductor components. There are linear ICs inside. There are current controlling components. Any misbehavior of the circuit, any ringing effect in the circuit, any spike here, maybe that spike is not stopped by EMI, that will directly impact on this IC. Any ringing from this side, in this path, in this path, that will damage this IC. When it is working good, we will receive 11.5 volt. Now I will remove IC and we will verify voltage again on this capacitor, and then I will install 400 volt capacitor and we will check that. If this resistor is not present, it is not controlling current. In fraction of seconds, this capacitor will blast. I remove this IC now, and I will check voltage on pin number 7 now. DC voltage 333 volt on the main capacitor. This is ground line. Pin number 7, 54.7 volt. This time this capacitor is discharging and it will not increase than this level until the capacitor is damaged permanently. Might be at specific limit it will damage permanently because its dielectric will make short circuit. Its insulation between positive and negative terminal will finish. That time it will damage permanently. Always discharge this capacitor because it is holding charge. Yes, it's good. The second question, VCC rectifier checking. This is VCC pin and we have VCC rectifier here, this winding and winding this end is connected to ground. In diode mode, if I will connect black lead at cathode, red lead at anode, it will give forward voltage of this resistor, of this diode. This is cathode, this is anode, 0.537. So this diode is good. What will happen if I will reverse the leads? We connected red lead at cathode, black lead at anode, but in parallel there is another circuit. This is reverse biased. Move this red lead here and we are reaching to this capacitor. Move this black lead here, we are reaching to negative terminal of this capacitor. That means if in reverse polarity we connect leads here, it will start to charge this capacitor and then multimeter will show off. Cathode, red lead, anode, black lead. It will show some reading and then it will return back to 0. And now First it will go to 0 and then it will display voltage. Yes, because capacitor will discharge through the multimeter. Now it will show indication. In this time when it was showing indication, that time this capacitor was charging. In one side VCC rectifier, it will show 0 and then voltage. Normally when we test diode will give directly 0.5 volt from OL, open loop, to 0.5 volt. But in this circuit, due to this capacitor, first it will show 0 and then 0.5. In this condition, if I will connect here, red lead at cathode, black lead at anode, we will see some values and then meter will go in OL, because this capacitor is now charged. This is open circuit and this is open circuit. So that is reason reading and then open. And in forward bias, first it will discharge this capacitor and sometime it will not discharge. If this capacitor is already discharged, that time we will not see 0 before. We will see directly 0.45. Now I will use 400 volt capacitor here. Now I will install this 400 volt 5.6 microfarad capacitor, and now we will see the response of the circuit. If the IC is good, this 400 volt capacitor will work normally. But in case the IC is bad, that time we will find the same voltage here on this capacitor. Another point, if we connect a capacitor in reverse polarity at just only around 10% of the rated voltage, the capacitor will blast, because these are polarity sensitive. Let's see the voltage value now. Because it is 400 volt capacitor, now it will not discharge the charging current. Now we have 325 volt, 334 volt here. Now we have 324 volt on this capacitor. That is the reason when this IC was damaged, it was not making load, because this time I removed IC. This IC is not present, and this capacitor will obtain the maximum allowed rated voltage of the circuit. Now I removed this IC, I removed the original value capacitor, and I installed higher rated voltage value capacitor, that is 400 volt capacitor, and it charged at same voltage value of this capacitor. Before this, the original capacitor, its internal dielectric was producing resistor due to leakage, but this 400 volt capacitor is now blocking voltage, and we are receiving approximately 325 volt here. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. How we can identify SMD diode from a PCB. Here is marking CR4, and if we see physical print, one line is connected at this line